What happens when a competitive programmer who's done numerous contests from Google, Facebook, Codeforces, AtCoder, you name it, does the Leetcode assessment? This is the first time I've touched a Leetcode assessment in 4 years, and I'm excited to see how I do this time around. And it has a 35.6% success rate, so hopefully we'll be part of that percent today. All right, each session will include up to 2 questions when you have an hour. All right, guess I'm starting right now. All right, an integer x is good if after rotating each digit individually by 180, we get a valid number that is different from x. So a number is valid if each digit remains a digit after rotation. 0, 1, and 8 rotate themselves, 2 and 5 rotate to each other, 6 and 9 rotate to each other, and the rest of the numbers do not rotate to any other number, and they're instantly invalid. Okay, so this is a standard implementation. N is only up to 10 to the 4, so we can iterate over every candidate that we check in the range from 1 to n. So cand is going to be a candidate value. It starts at 1 and it goes up to n. And we can start that with a for loop. And res is going to be the output value for this method, aka the result for the number of good integers in the range. Now, the way that I'm going to approach this is I'm going to create a map over here. And I'm not going to use a actual hash map. I'm just going to use an array in Java. And the way I'm going to implement it is the following. I'm first going to populate the entire map with all negative ones. Map 0 becomes 0, map 1 goes to 1, and map 8 goes to 8. And then now we handle the 2 and 5 case. So map 2 is going to be equal to 5, and map 5 is equal to 2. And then the last case we handle is a 6 and a 9, because funny number. So basically what this does is that if I want to rotate a digit, d, then I can just use the value map at index d. We can generate the number itself. So rotated is going to be equal to 0. Now, we do have to be a little careful, I guess, in how we implement this. So I'm going to have to find a way to retrieve every digit of the candidate. And the way I'm going to do that is with a while loop. So the ones digit is always going to be cur mod 10. And if we want to delete the ones digit and shift all other digits to the right, then I can just do integer division on cur. So cur divided by 10. I want to use an outer loop here because if this digit maps to -1, then we want to throw out this candidate. That means that digit cannot be rotated and it's not going to generate a valid number. The value is going to be different if and only if there's a 2, 5, 6, or 9 in the array. So we don't even need to calculate the new rotated value. All we need to do is to keep track of if we've encountered a 2, 5, 6, or 9. So I'm going to go ahead and do that. And then will be set to true if the digit is equal to 2, 5, 6, or 9. And a neat way we can check that is to check if map of digit does not equal to digit. And if we've seen at least one of these special digits, then we increment our result variable. Let's go ahead and run this on the input. 10 and 4. Let's go ahead and submit and see if it works. All right, that's question 1, success. Move on to question 2. You're given an array representing a row of seats where seats at I equals 1, representing a person sitting in the I seat, and seats I equals 0, representing the I seat is empty. Okay, there's at least one empty seat and at least one other person sitting. Alex wants to sit in the seat such that the distance between him and the closest person to him is maximized. Return that max distance to the closest person. Immediately, what we can think of this problem as is we want to sit Alex in an empty chair. And if we consider the intervals of empty chairs in the array, we want to always sit in the middle of that interval because that's how we stay the farthest from his endpoints. So if we can iterate over the length of all of these intervals of empty seats, then we can find the answer by taking the maximum length and dividing it by 2, rounding up. So let's go ahead and do that. I'm going to res, once again, is going to be what we eventually return in this function. I'm going to set it to 0 initially because worst case scenario where if the farthest we can get from a person is literally 0 units apart. So I'm going to set a tag to be equal to seats at 0, and the length of this running interval that we're keeping track of is initialized at 1. And we can think of this as we keep track of what kind of interval we're currently on. And if this interval ever changes the state, in other words, if it becomes 1 or 0, then that's the start of a new interval. So if the color of the current interval that we're on is the same as the new seat that we just considered, then that's still part of the same interval, so we just increase length by 1. Otherwise, this is part of a new interval. Before we update this new interval, we check our old interval and see if it's an interval of empty seats. And we check that by seeing if color is equal to 0. And if so, we want to set it the maximum of the current value of res and the length of the array plus 1 over 2, because that just does ceiling division. And then we just update this new interval. So color is going to become the new color that we just encountered, and the length becomes 1 because we started a new interval. And one thing you have to be careful of is once we exit this for loop, we have to compare this length variable one more time because this corresponds to the last interval. And we haven't processed the length of that last interval yet because we only process intervals when those intervals end or then the next one begins. All right. And then we just return res and see if we can run them on the test cases. We output 2 for this one. Let's go ahead and submit. Oh, wow, we got wrong answer. Output 2, expected 3. Why is that? Oh, okay. We want to consider endpoints because we want to maximize the closest person we're at. If color is equal to 0, this is the last range, so it's not going to be length half of a length because we can just sit at the very end of this range. So over here is just length. And then we also want to consider the first endpoint. And it's probably easiest to do up here by keeping a Boolean variable. First is going to be equal to true. If first, then res is going to be compared with the full length variable. Otherwise, we want to cut it in half. And when we ever get to this line of code, this is a new interval, so it cannot be the first interval anymore. So we set it to false over here. All right, let's go ahead and finish the session. Time spent 10 minutes, 17 seconds, and time allotted was 1 hour. All right, so the score report just generated. We beat 94% of all users. That was pretty successful, I would say. I didn't know there was a more detailed report. As you can see, we scored higher than over half of employees from Google, which sounds really impressive, but I have no idea how they even calculate this metric, so I'm going to take it with a little grain of salt. If you enjoyed watching this, let me know down in the comments below. See you guys next time.